Okay, this is basic proof writing. We're going to do page 87, number 11 from your textbook, using addition and subtraction properties. And as you've noticed, I have already given my, drawn my chart, statement on the left, reason on the right, and the picture diagram from the textbook. I think that one thing that we need to know is, remember that a proof is like a map, and I want to know where is it that I'm headed. So I'm going to write my conclusion statement. This is where we're going. Conclusion. Angle BAC is congruent to angle FAE. Now, what's given? Okay, the problem has two givens. One is angle BAD congruent to angle FAD. We always do our givens first, marking our picture as we go to figure out what is it we need to do next. So I'm going to mark BAD congruent to FAD. And notice I'll take this arc and go all the way across. And then another green arc all the way across. So those two angles are congruent to one another. Well, at the moment that's not going to tell me anything, so I'm going to go on to my next given, which is ray AD bisects angle CAE. And again, we need to mark in the picture exactly what is given here. So I'm going to use another color. Let's try purple. AD bisects CAE. So AD is this ray right here going through this angle CAE, which is kind of that middle angle. So I am going to say, since it bisects, that means that this angle is congruent to this angle. Let me put a little mark in there. So the purples match, but I also put the little tick marks here to show that they also are matching angles. Okay, now from that, I see something right away. And what I see is you have this larger angle, BAD, and another larger angle, FAD, that are congruent. And then inside of those two angles are two other congruent angles, CAD and EAD. So again, this is about addition, subtraction properties. This would be the subtraction property, because I can take this green angle and take away the purple angle on both sides, and I'll be left with this smaller angle, which is exactly what we're trying to prove up here. BAC congruent to FAE. So I'm going to go ahead and remember, I've drawn that the two angles are congruent, so now I want to actually say that in my proof. So step 3, angle CAD is congruent to angle EAD. And how do I know that? Well, that was from the previous step. If I have an angle bisector, I get congruent angles. So remember, your proof sheet gives you these reasons listed in the proper, precise language that I want you to use. So we're going to say, if a ray bisects an angle, it divides it into two congruent angles. And those are the purple that I've marked, CAD, DAE. Well, now I actually can go ahead and go to my proof step, my conclusion. Angle BAE congruent to angle FAE. And how do I know that? Well, that's the subtraction property at work here. So we have the larger angles, BAD and DAF, are congruent. Take away their smaller parts inside, CAD and DAE, and we have two congruent angles of BAE and FAE. And how do we know that? Well, that's by the subtraction property. And the subtraction property says, if you'll find this, addition, subtraction properties, on page 83 of your text says if congruent angles, I'm sorry, it's on page 84 of your text. This is the subtraction property. So if congruent angles are subtracted from congruent angles, the differences are congruent. So if congruent angles are subtracted from congruent angles, their differences are, let me just use a symbol there, congruent. Remember that BAC and EAF are the difference between the larger green angle, BAD, and the smaller purple angle, CAD. So there you have a simple proof using the subtraction property, and that can be found in Chapter 2, Section 2.5 of your textbook. I hope this helps.